Hi, everyone. Welcome to another session of Science and Technology with Miss Hinkson. We have been looking at the properties of matter. So it's basically the characteristics or the traits of the substances that we are trying to analyze. So you've looked at density, you've looked at volume, you've looked at mass, we've looked at the idea that there are non-characteristic properties and characteristic properties. And now we're going to look at acids and bases because they have their own properties. So remember, keep in mind that these techniques to figure out the properties of matter are important. If ever you were in the lab and you had an unknown substance, running tests that look for these properties would help you figure out what your unknown substance is. So if you wanted to describe a substance, you should be giving its mass, you should be giving its volume, its density if you know it. If not, you know how to calculate it. What does it look like? What are its qualitative properties? What color is it? Is it transparent? Does it have a color? How does it behave in the presence of indicators? So these are all the things that you will be investigating should you have an unknown substance. So every day you encounter acidic or basic substances. So all around your house, the foods you eat, just you're exposed to acids and bases all the time. The level of concentration, well, that will depend on what you are encountering. So acids and bases, as I mentioned, there are some foods even, and we'll look at that are acidic or basic, or they're alkalinic. Um, but if it's at a very, very low concentration, they're not dangerous. However, if it's a high concentration and it's a high acidity or basis, alkalinity, sorry, they can be very dangerous. High concentrated acids and bases can destroy the tissue of your skin, of human bodies, and those are corrosive. So, if ever you are handling household products, it's very important that you remember that they can be dangerous, and most of the time they're either acids or bases. So you should be wearing gloves and protecting yourselves. So let's take a look at acids for a moment. So as I mentioned, you are exposed to acids every day. So there are properties or ways that you could identify if what you're encountering is either an acid or a base. You see here vinegar that you have in your house. It's often used for cleaning chicken sometimes. I know my mom used to use that to clean chicken or put it in food, or you had salt and vinegar chips. Vinegar is actually an acid, and its scientific name is acetic acid. So when you have vinegar, it's a diluted version of acetic acid, meaning it's acetic acid with water added to it. If you've been eating oranges or lemons, then those are acidic. And your batteries have acid within them. So, fruit juice, soft drinks, and the gastric juices secreted by the human stomach are all acids. So, within your stomach, you have acids, and these acids are what helps your body break down the food that you've ingested. They can be identified by their sour taste. So acids have a sour taste. Don't ever taste batteries, okay? But acidic acid or vinegar, citric acid, you can taste that it's sour. We are going to look at this idea of litmus paper, which is an indicator, which is used to detect whether you have an acid or a base. So blue litmus paper turns red on contact with an acidic solution. We'll talk about that more later. Now, bases. Bases are often in the, let's say, the household cleaning products that you have, tonic water, baking soda, stuff like that are known as bases. So bases are found in many cleaning products and in some heartburn medication. So a lot of the time, heartburn or acid reflux, those stuff are caused by high levels of acid. So you take a basic medication so that it's mainly a base. And this is something you will learn later. It neutralizes the acid, right? And so now instead of having an acidic environment, you'll have a neutral environment. So neutral is something that has a pH of 7. We'll look at that. For example, mostly, so water should have a pH of 7. Water should be neutral. So blood and salt are also slightly basic. Basic solutions have a bitter taste. So we talked about acids and we mentioned that acids have a sour taste. Well, bases have a bitter taste. They feel slippery to touch because they react with the oils of the skin, forming a kind of soap. So again, we'll talk about this idea of indicators more, but this is again talking about the litmus paper. So before with the acids, blue litmus paper turns red in the presence of an acid. Now when we have red litmus paper, if it's dipped in a basic solution, it will turn blue. So again, red litmus paper will turn blue if it's been exposed to a base. So we're talking about acids and bases, and we're talking about their taste. Obviously, I hope you are aware that tasting products that you don't know is not a good idea. You should not be tasting things that you don't know. You should not be tasting household products, right? So this is not an accurate way to test whether a solution is an acid or a base. This is not a good way to investigate what you have. So you should not be tasting unknown substances. And again, you should not be tasting substances that are not food or drinks. So this is actually in your textbook. It is basically showing you the things that you have been exposed to that you see regularly that are acidic or basic substances. So over here we have the name hydrochloric acid. It is concrete strippers, so to like break down concrete, toilet bowl cleaner, right? So then we have sulfuric acid, production of it's used in the production of plastics, fertilizers, and dyes. Electrical conductor for car batteries. Vinegar is another form of acid. Its scientific name is acetic acid. It is a cooking ingredient, or it's used in food preservation, right, to keep food from spoiling. Now that was acidic substances that you may have encountered. Basic substances, for example, ammonia, household cleaners, and production of fertilizers and explosives. That's what you use ammonia for. If you've used the brand a window cleaner, let's say, for example, Windex, you'll look at the ingredients and there will be ammonia in there. Baking soda, or sodium bicarbonate, its scientific name. It's a cooking ingredient or an antacid. Bleach, which is sodium hypochlorite. It's a disinfectant, a bleaching agent. So you've used bleach, they use bleach to disinfect things, but you've also seen that bleach is used to get white colored clothing to be the whitest that it can be. So we're going to talk about the pH scale more later, because the pH scale gives you a level of how acidic or basic something is. You'll see here that this diagram shows you the things that you've been exposed to, and discusses what their pHs are. So this side, so first of all, anything that is 7 is neutral. So that has stuff like water would be a pH of 7. Anything above 7 would be considered basic, or alkali is another word for basic. All right, so you'll see here that the numbers are increasing. The increasing level over here, going above 7, tells you how basic something is. So over here, right after 7, around 8, we have a weak base. But if you go all the way up to 14, that is a very strong base. Very, very, very strong base. Now, if you look in terms of acid, 7 again is neutral. Anything below 7 is acidic, and the acidity increases as you move to the left. So something with a pH of 6, which is very close to 7, is a weak acid. But if you go further away from 7, let's say 0, you have a very strong acid, and you see the caution sign there with hydrochloric acid. Very, very strong acid, corrosive. It will burn you if you are exposed to it. So I've spoken about this. Many of the foods and drinks that we consume can be categorized as acids or bases or alkalis. So over here, pH of 4, right? So that's pretty acidic, but not that acidic. pH of 0 means very, very, very strong acid. So pH of 4, we have breads, alcohol, colas, sugar, etc. Mild acids, right? So this is a strong acid because it's considered a strong acid because we're talking about food, stuff that we're consuming. Obviously, it's not the strongest acid, pH of 0 would be, but we would never be consuming anything that had such a strong, that's such a strong acid or such a low pH, right? So things that are mildly acidic, meat, fish, legumes, nuts, and dairy. Over here, this is the pH of 7, which means neutral. We have things that are basic. Fruits, vegetables, avocados, almonds, asparagus, cayenne pepper, melons, and kelp. So remember, next time you're eating a food, see if you can figure out whether it is acidic or basic. And how would you do that in regards to food? What would you be looking for? I'll give you a minute to think about that. Have you thought about it yet? All right, so if you remember in the beginning of this presentation, I discussed that acids are sour to taste, and bases are bitter to taste. So if you taste a food and it's extremely bitter, then most likely it's a base. You taste a food and it is very acidic or it tastes sour, then most likely you're consuming an acid. So this is one of my favorite candies. I am a sucker for sour candy. I love sour candy. But you would imagine, or you know by now, because it is sour, that it is acidic. Okay, and if you look at the ingredients of the Sour Patch Kids, you'll see that there are 2 types of acids in there, tartaric acid and citric acid. I mentioned to you before that acids and bases can destroy tissue, right? Skin tissue or any kind of tissue in a living organism. So if you have ever gone on a rampage and have eaten too much sour candy, you immediately feel like your tongue is cut, and you can look at your tongue and it looks like it's been chopped up almost. And that is because of the acid. So consuming too much sour candy is not good because the acid can destroy your tongue and inside of your mouth. Good thing your skin heals and it has its own mechanism to counteract stuff like that, so it won't remain that cut up feeling forever. But still, it's not good to consume too much acid. And if you are aware of how ingredient labels work, the stuff that's closer to the beginning are the things that are more in high concentration. So there's a lot of it. And as you go down, these are the things that are not in high concentration. There's not a lot of it. If you look at where tartaric acid and citric acid are located, they're very close to the top. So that means there's relatively a lot of this acid in the candy. So how do we determine if something is an acid or base? So if you're in the lab and you have an unknown substance and you are trying to describe this substance to the fullest, you're going to want to figure out, is this an acid? Is this a base? Is this a salt? Salts have a neutral pH. And if you're in the lab and this is not food you're talking about, we made it very clear that you should not be tasting these substances. Yes, if you have a food, it's fun to taste whether it's sour, because if it's sour, it's an acid, or if it's bitter, it's a base. But what do we do when we're in the lab and we want to figure out if we have an acid or a base? So pH is an accurate measurement scale. pH is a measure of how acidic or basic a substance is. The range goes from 0 to 14, with 7 being neutral. pH is less than 7 indicate acidity. pH is greater of 7 indicates a base, okay? So we need something that measures the pH, because that will tell us if we have an acid or a base. As I mentioned before, if you look at the pH scale, as you move to the left from 7, it's increasing in acidity. And if you look to the right of 7 and you move further away from it, it's increasing in alkalinity, right? So it's becoming a stronger and stronger and stronger base. Okay, so we have different indicators. Okay, so an indicator is what is used to detect whether we have acids or bases. So as I mentioned, it is extremely dangerous to try to determine acidity or alkalinity of a substance by tasting it. So we are not tasting things in the lab. That is something that they did hundreds of years ago, but many scientists died because of this. So you can use an indicator to measure the acidity or alkalinity of a substance. An indicator is a substance that changes color in the presence of an acid or a base. Obviously, if the solution you have is not an acid or a base, the indicator will not change color. Lichens, red cabbage juice, tea, and grape juice also change color in the presence of acidic or basic substances. So these are natural indicators that will change color, whether they're in this, depending on if they're in the presence of acid or a base. So here we're going to look at a video later that discusses this, but we have an indicator that comes in the form of a liquid called phenolphthalein. Phenolphthalein only changes color to this fuchsia pink color if it's in the presence of a base. So if you add phenolphthalein to a solution and it turns pink, then you have a base. And the color of the pink and how pink it is or fuchsia it is increases depending on how basic your solution is. If it is a slightly strong, if it's a slight base, right, so somewhere around 7 or 8, the pink will be very faint. If you have a very, very strong base that's closer to 13 or 14, it'll be very fuchsia and you won't really be able to see through it. It'll be very pink. We also have this, we're going to look at this closer. These are universal indicators, which are very helpful because they change all these different colors based on the pH that they've been exposed to. So it'll help you. You can use this one paper to tell you whether you have an acid or base, and it'll basically tell you around what the pH of your substance is. Then we have the classic blue litmus paper and red litmus paper. Blue litmus paper will turn red in the presence of an acid, and then red litmus paper will turn blue in the presence of a base. So this is just what we just discussed. We are comparing here, this is in your textbook, the blue litmus paper and the red litmus paper. If you put blue litmus paper in an acidic substance, it'll turn red. If you put red litmus paper in an acidic solution, it will stay red. If you put blue litmus paper in a basic substance, it'll stay blue. If you put blue litmus paper in an acidic solution, if you put red litmus paper in a basic solution, it will turn blue. Now, if your litmus papers, neither of them change color, It's because you have a neutral substance. It could be something like a salt solution. So, as I mentioned before, a universal indicator is a blend of pH indicator solutions designed to identify the pH of a solution over a wide range of values. Universal indicators can come in liquid form. So, this over here is liquid. And so you would add it to a solution, and depending on the color it turns, you look at the color wheel, it'll tell you the pH. Or you can have a universal indicator in the form of paper, and it's like these little strips, and you dip it in. You would even see these kind of indicator strips in a lab or in a hospital when they're testing, let's say, a pee sample or something like that. They use indicators, right? So they dip it, and it'll tell them what it is. So it's not only indicators do not only indicate if you have an acid or a base. There are several different types of indicators, and there are ones that can indicate whether you have the presence of a certain substance that you're looking for. So again, you have natural indicators. We mentioned that before. There are different things that are natural, and you can find them in our environment, and they change color based on if they're in the presence of acids or bases. So red cabbage juice is a natural indicator as it changes color in different pH. Pretty cool. Orchid flowers are natural indicators. Berries, grapes, and berries and grapes are natural indicators as well. So we're just gonna look at this video. This is a video showing people actually making red cabbage indicator in their home.
Today on Sci Guys, acid-base indicators. Welcome to Sci Guys. I'm Ryan.
And I'm Adam. Today we're going to be making an acid-base indicator using red cabbage.
Poiple cabbage.
It's called red cabbage.
It's poiple.
Its name is red cabbage.
Poiple cabbage.
An acid-base indicator is a solution that changes color in the presence of an acid or a base. It can be a sudden change at a specific pH or a gradual change through many colors as the pH changes.
The equipment you need for this experiment includes a couple of glasses,
a blender,
coffee filters,
and a funnel. We're also going to need a few ingredients from the fridge and pantry.
The items we need from the pantry are baking soda, vinegar, and distilled water.
The ingredients we need from the fridge include lemon juice and a red cabbage.
The last two items we need are ammonia and antacid tabs.
The safety equipment we're going to need today includes gloves, goggles, and an apron or lab coat to protect from spills or splashes. Also, since we're dealing with hot water and sharp objects, make sure you have adult supervision. So the first step for our experiment is to add 4 cups of warm distilled water to our blender. Next, we add 2 red cabbage leaves. Put the lid on securely. Holding the lid, give it a few pulses.
The second step in our experiment is to take your coffee filter in your funnel and place the coffee filter inside the funnel. This will help prevent any small pieces of cabbage from getting into our solution. Place your funnel and coffee filter over top of another container and pour your blended solution through the coffee filter. Make sure to take any large pieces of cabbage out before you start this filtration process. The third step is take your cabbage solution and pour it into several different glasses. Make sure to leave enough room for the rest of the liquid we'll be adding to test for pH. The first solution we're going to test is ammonia. When ammonia is added, it turns our solution a green color, which indicates that it's a strong base. The second solution we're going to mix with our indicator is a little bit of distilled water mixed with baking soda. The baking soda turns our indicator blue, which tells us that it's a weak base. The next solution we're going to add to our indicator is tap water. Tap water turns a solution a very slight blue color, but it still looks like a shade of purple. This tells us that the tap water that we tested is slightly basic but close to neutral. The fourth item up for testing are antacid tabs. When we add a tablet to our indicator, carbon dioxide is produced, and because carbon dioxide is acidic, the color changes to maroon. This is not the end of our color change. Once our solution is done fizzing, the other ingredients in our tablet cause the pH of our solution to shift slightly towards a neutral pH, which changes the color slightly purple. Vinegar is our next solution that we're going to be adding to our indicator. When we add vinegar to our solution, it turns a very bright red or pink color. This color change means that vinegar is acidic. Solution number 6 that we'll be testing is lemon juice. Lemon juice turns our solution a bright red or pink color, which means that lemon juice is also an acidic solution. Let's look at this experiment a little closer. First, let's look at what pH is. pH is a scale that we use to measure acidity. The lower the number is on the scale, the more acidic the solution is. Water is a neutral solution and has a pH of around 7. Vinegar, which is one of the most common household acids, has a pH of 2.2. pH is determined by the number of hydrogen and or hydroxide molecules a solution has. One of the ways that scientists determine the acidity of an unknown solution is with a pH indicator. There are many different kinds of indicators, but what they all have in common is they all change color based on the pH of a solution. The natural pigment present in red cabbage is called anthocyanin and is an example of an indicator. These indicators show the pH of a solution by changing color. Now, the color of an object that we see depends on the shape of the molecules the object is made of. White light contains every color in the rainbow, and each color has a different wavelength. Molecules of different shapes reflect and absorb different wavelengths of light. The wavelength of light that reflects off a molecule is the one that reaches our eyes, and that determines what color we see, while all other wavelengths are simply absorbed. When we add an acid to a red cabbage solution, we flood it with hydrogen molecules, which causes the indicator to change shape and reflect red wavelengths, making the solution look red. If we add a strong base, there is instead a high amount of hydroxide molecules, causing the shape of the indicator to change color and reflect green or yellow light. Solutions that are only slightly acidic or basic will change the color of the indicator to shades of maroon or blue, respectively. The really neat thing about our cabbage indicator is that the shape of our molecule is reversible. So if we alternate adding acids and bases, the color can continue to change back and forth, provided you don't add a strong solution, such as bleach, that will eventually destroy the pigment completely.
Well, that's it for acid-base indicators. I hope you enjoyed it.
If you like this episode, subscribe to us for future updates and let us know in the comments below.
You can also find us on Facebook and on Twitter.
And if you have any questions related to this episode or about science in general, let us know in the comments below or message us on Facebook and we'll try to help you out. Today on Sci Guys, acid-base indicators.
Alrighty, so you just saw a video where they actually made an indicator at home. So you could try that if you ever you wanted, but yeah, there were some products there that were a little bit dangerous. So I wouldn't suggest that you do it alone. All right, so this is a page out of your textbook. It discusses, again, the level of pH of different things that you may find around your home. So we see the oven cleaner. Like, I don't know if you guys have ever used oven cleaner. Ask your parents. The oven cleaner, sometimes your oven is so dirty and you take a sponge and you wipe it, and no matter what, you can't get rid of that buildup, that grime. And then you spray it with an oven cleaner and you leave it there and then come back, and that stuff wipes off so easy. And that just shows you how aggressive oven cleaner is. And you see here, its pH is near 14, which means it is a very, very, very strong base. So also when you're spraying the oven cleaner, where you're spraying it should be very ventilated because you don't want to inhale too much of that. Open a window. You know, we've been wearing masks recently, and so masks aren't only to keep away bacteria or microbe. You can also put on a mask so that you don't inhale too much of these cleaning products. So again, this is a page in your textbook. You see that human blood is slightly basic, not very basic, because it's very close to pH of 7, which is neutral, like water, but it is more to the right, so it is considered a base. Milk is acidic. It is just a little bit below pH of 7. And unfortunately, you would think that you'd want rain to be neutral, right? Water. But we know that because of the presence of carbon dioxide and also because of the pollution from factories and whatnot, that we have acid rain. So it makes sense that the pH is below 7, which indicates that it's an acid. So we'll just watch one more video.
While it is possible to quantitatively measure the pH of a solution using a device known as a pH meter, there are also ways to determine pH qualitatively. In this lesson, we will learn about indicators, which help us indicate the pH of a solution. An indicator changes color depending on the pH of the solution analyzed. Because of this, they are also known as pH indicators. Universal indicator is very versatile as it can measure pH across the entire scale from 0 to 14. It is not a single indicator, but rather a combination of various indicators. If you look at the color changes of universal indicator according to the pH of a solution, you will find that it resembles a rainbow. If universal indicator solution turns deep red in a solution, it means that the solution is strongly acidic, with a pH of 1 to 2. If the universal indicator solution turns green, it means that the solution is neutral, with a pH of 7. If the universal indicator solution turns dark blue or purple, it means that the solution is strongly alkaline. Universal indicator paper works in exactly the same manner. Litmus is another indicator commonly found absorbed onto paper as litmus paper. Blue litmus paper turns red under acidic conditions, pH less than 7. Red litmus paper turns blue under alkaline conditions, pH greater than 7. Phenolphthalein is an indicator commonly used to determine the endpoint of a strong acid, strong alkali, or weak acid, strong alkali titration. It goes from colorless to fuchsia pink at a pH of 8.2. Methyl orange is used to determine the endpoint of either a strong acid, strong alkali, or strong acid, weak alkali titration. It is red at a pH lower than 3.1 and yellow at a pH higher than 4.4. In conclusion, indicators are substances that change color at a certain pH. The point at which an indicator changes color is known as its endpoint, which can be at any pH. Common indicators that you will encounter are universal indicator, litmus in the form of litmus paper, phenolphthalein, and methyl orange. Well,
Alrighty, so that concludes our section on acids and bases. Again, we're looking at the properties of matter. And another way to describe a substance is it an acid? Is it a base? Not, is it neutral? And so we would use an indicator to help us find the pH or the range of the pH. And that would help us determine whether we have an acid or a base. So if you look here, I've got reading for you, of course. So if you turn to pages 183 to 188, you can read, or you will read, about acids and bases. Again, I'd like to thank you for watching another session of Science and Technology with Ms. Hinkson. As usual, if you have any questions, any comments, please email me at hinksons@loyola.ca. That is HINKSONS at LOYOLA, Loyola.ca. Have a great day.